Welcome to True Projects. In this video, we are going to explain about a project titled Malaria Disease Classification using the Transfer Learning. Malaria is a fatal disease transmitted by mosquitoes, which is caused by the Plasmodium parasite infecting the red blood cells and leading to the symptoms like fever, fatigue, and headaches. With millions of people at risk annually, it particularly affects the Africa. If left undertreated, malaria can have deadly consequences. According to the World Health Organization, 3.2 billion people are at high risk worldwide, and in 2020, there were approximately 241 million cases and many more deaths in Africa. Preventive measures include endless repellent use, sleeping under mosquito nets are taken. Malaria is a fatal disease claiming the lives of more than many individuals of 5 lakhs. The conventional methods for diagnosing the malaria relies on manual microscopy, which is time-consuming and susceptible to human errors. A new automated approach has been proposed for malaria diagnosis, which utilizes the intensity characteristics of Plasmodium parasite and erythrocyte. By collecting the images of infected and non-infected erythrocytes and employing the transfer learning model, the system can discern the subtle differences between the infected and healthy cells, which enabling the accurate malaria diagnosis. This automated technique has the potential to save the life by expecting the diagnosis process and enhancing the diagnostic accuracy. These are the requirements that are needed to build this project. Software requirements are Python IDEL with version of 3.7 or Anaconda 3.7 version or Jupyter Notebook or Google Colab. Hardware requirements are operating system as Windows or Linux, processor of minimum Intel i3, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to understand the flow of project, first importing the libraries. In this module, the required Python libraries and frameworks are imported, like libraries for machine learning and the transfer learning tasks are loaded, such as TensorFlow for neural network modeling, NumPy for numerical computation, OpenCV for image processing, Flask for web development, and others as of needed. And the second one is exploring the dataset. In this step, the dataset containing the images for malaria diagnosis is explored. This dataset includes both the infected and non-infected erythrocyte images. Data visualization techniques may also be employed to understand the distribution of images. And the third one is image processing. In this module, the techniques are applied to enhance the quality of images and make them suitable for training the model. This also involves resizing the images to a consistent resolution, normalizing the scale pixel value, and applying the data augmentation to increase the diversity of the training set. And the fourth one is splitting the data to the training and testing. To evaluate the model's performance, the dataset is divided into the two parts, the training set and the testing set. The training set is used to train the many algorithms, and then the testing set is used to assess the accuracy on the unseen data. And the fifth one is building the module. In this module, various learning architectures are constructed and implemented for malaria diagnosis. And the first one is CNN. CNN is also a type of deep learning model designed to process and analyze the visual data such as images. It is widely used for image recognition and computer vision tasks. It consisting of convolutional layers that apply filters to the input data to extract the features hierarchically. These features are then passed through fully connected layers for the classification, and the CNN are effective at capturing the spatial patterns and local dependency in the images. And the second one is DenseNet 201, is a specific variant of the DenseNet architecture, which is a deep learning model known for its densely connected layers. In this, each layer is directly connected to the every other layer, promoting the feature reuse and information flow throughout the network. This design allows for efficient parameter sharing and alleviates the vanishing gradient problem. DenseNet 201 is particularly popular for image classification tasks and then can achieve the high accuracy with fewer parameters compared with the other model. And the NASNet Large as a neural network architecture involves automatically searching for the optimal architecture using the reinforcement learning or the optimization algorithm. Is designed to provide excellent performance while keeping the model size manageable. It's suitable for the various computer vision tasks and learn to adapt to different data sets, making it versatile choice for the transfer learning. And the Inception Net is also known as GoogleNet, widely used CNN architecture known for its deep and complex structure. It introduced the Inception module, which performs multiple convolutions with different filter sizes in parallel and concatenate their output. This approach allowed the network to capture both fine-grained and high-level features effectively of the transfer learning, where InceptionNet is known for its computational efficiency and has been a winning model in various of imaging recognition competitions. An exception, and it's a short form of extreme inception as an extension of the inception net architecture. It replaces the standard convolutional layer with depth-wise separable convolutions, which significantly reduce the number of parameters and computation. Exception achieves state-of-art performance in image classification tasks while being more efficient than of traditional CNN. And the sixth one is hybrid model. It refers to the combination of the network architecture of CNN and RNN and transformers tailored to a specific of the task for the defined dataset. And the mobile net is also an of the technique that will be evaluate the accuracy of the task and will take to advantage to strength of the different model and to increase the performance of the image classification while before more efficient than of the other modules. And in the training the model, the constructed model or trained on the training set using the appropriate optimization technique and the loss function. During the training, the model learned to recognize the subtle differences between the infected and non-infected erythrocyte images and optimize their parameters to achieve the better accuracy. And the seventh one is user gives the input. The project includes a web-based interface using the Flask framework, enabling the user to interact with the system. User can upload their erythrocyte images through the web application. And the eighth one is the given input is pre-processed for prediction. The user provided erythrocyte image or pre-processed before being fed into the trained model for prediction. The pre-processing ensures that input image are in the suitable format for the model to make the accurate prediction. And the ninth one is trained model is used for prediction. The pre-processed erythrocyte images are passed through the trained different models that are used in this project. For the prediction, each model will classify the image as infected or non-infected based on the learning features during the training. And the final one is final outcome is displayed. The predictions made by the models are presented as the final outcome. The web application interface will display the result to the user, indicating whether the erythrocyte is in the uploaded images are infected with malaria or not. This outcome can aid in the prompt diagnosis and treatment planning for the malaria patients. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder consisting of different files. The dataset folder consisting of testing and training dataset consisting of various images within each model. And the model folder consisting of H5 files, which is used to load the information at the time of the project execution and containing the algorithm's information within it to perform the certain tasks such as of the prediction, accuracy and many more. And the sample folder consisting of the images which is used for testing the model's performance. and the static folder consisting of the files related to the CSS, JavaScript and Bootstrap files. And the template folder consists of the HTML pages which is used in this project. It typically includes the files like index, about, notebooks, sign in, sign up and after. And the app.py file likely contains the information related to the front-end logic. It could include the code written in Python that handle the server-side operation such as processing user requests, interacting with the database, and generating the dynamic content. And the IPYNB file is a Jupyter Notebook file which contains a combination of code, graph, and output all in one. It allows the user to write and execute the code in individual cells, making it a popular choice for the data science. And the signup.db file appears to be the database file used to store the user information. Mainly the Jupyter Notebook consisting of all the information like of testing, sampling, and comparison graph and training the models within it. For the execution of the project, we need to copy the address of this folder and open the Anaconda prompt. And we need to classify the disk, and my folder is present within of fdisk, so I'm writing a command of f and click enter button, and write and command of cd space and paste the address of the code folder and click on open button, click on enter button. And here we need to write another command like of python space app.py. By using this command and this Anaconda prompt will execute the Python script and perform a runtime check for any syntax error or the logical issue, and click on the enter button. After running the app.py file, the Flask framework will host the application locally at the default address as of this, and we need to copy this local link for the provided framework and paste it on any web browser, and I am using to prefer of Chrome. And copy this link and click on enter button. Here we get and redirected to the home page consisting of home and login buttons, and click on login button. Here we get as login page, and we can see also the sign up button which is used to initiate the registration process. By clicking on it, it will take to the registration page where we need to provide the necessary details to create a new account. But I am having the existing account, so I am going to this login page and entering the admin as of username and of password, and click on login button. By this, it redirected to this page consisting of this choose file button and upload button, and having the home notebook and sign out buttons. And these are the different pages HTML files which consisting of the information of home page, notebook page consisting of the Jupyter file, and sign out will close this web interface. And click on choose file button. It redirected to the sample folder that is present in this code folder, and selecting the any one of this image and click on open button, and then click on upload button. By this, it is classified as output image you have uploaded is infected and detected as trophozoite, and click on try again button. By this, it redirected to the first sign in of page, and click on choose file, and here select any one of the image and click on open button, and click on upload button. Here it detected as of trophozoite. In this way, we can detect and classify the malaria disease by using the transfer learning. And conclusion, we use transfer learning and fine-tuning to improve the performance of the pre-trained model for malaria detection. The performance of the models is influenced by their architecture, training framework, and the volume of training data. In this study, we did not use the dropout as this can lead to the information loss from the images. We developed a web-based interface to make it easier for the end users to use the model and categorize the blood smear photos. This has the potential to reduce the stress on the medical field workers while simultaneously boosting the speed with this diagnosis are made. In future, we plan to focus on improving the performance of the CNN model by optimizing the architecture. This will result in significant increase in the accuracy of the malaria detection.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.